Today, we'll be solving LeetCode 102, binary tree level order traversal. In this problem, we are given the root of a binary tree, and we need to return the values of its nodes level by level, starting from the top and going to the bottom. Each level should be stored in its own list, and all of these lists should be grouped together into a larger list. This is a perfect problem to apply the breadth-first search pattern, often called BFS. BFS is useful here because it visits nodes level by level, exactly the order we want for the output. The natural data structure to help us with BFS is a queue, because queues process items in a first-in first-out order. This means the first node we visit will be processed before any new nodes we add to the queue. Let's walk through the idea. We will start with an empty list called result to store all levels. If the root is empty, we simply return this empty result. Otherwise, we create a queue and put the root node in it. Then, while the queue is not empty, we figure out how many nodes are in the current level. We process exactly that many nodes, collecting their values into a list for this level. While processing each node, if it has a left child, we add that left child to the queue. If it has a right child, we add that right child to the queue as well. After processing all nodes for that level, we append the level list to our result. Once we finish processing all levels, we return the result. Now let's go through the code in detail, line by line. First, we check if the root is empty by saying if not root. This means if the root does not exist, we return an empty list because there are no nodes to process. Next, we create an empty list called result. This will eventually hold all levels of our tree in order. Then, we create a queue to help us process the tree level by level. We store the root node inside this queue as the starting point. Now we begin a while loop with the condition while queue. This means we keep looping as long as there are nodes left to process. Inside the loop, we first find out how many nodes are currently in this level. We store this in a variable called level length by setting it equal to the length of the queue. Then, we create an empty list called level. This will store the values of the nodes for the current level we are processing. Next, we loop through the nodes in the current level using a for loop that runs level length times. Inside this loop, we remove the first node from the queue using pop left, which gives us the node to process. We then take the value of this node and append it to our level list. After that, we check if this node has a left child by saying if node.left. If it does, we add that left child to the queue so it will be processed in the next level. We also check if this node has a right child by saying if node.right. If it does, we add that right child to the queue as well. Once we finish processing all nodes for this level, we append the level list to our result list. When the while loop ends, that means we have processed all levels in the tree. Finally, we return the result list, which contains all levels from top to bottom. The time complexity of this solution is O of n, where n is the number of nodes in the tree, because each node is visited exactly once. The space complexity is also O of n in the worst case, because the queue might hold all nodes in the largest level at once. And that's how you solve LeetCode 102. Thank you for watching and let's keep learning.